On the morning of August 5th, 2026, at 2:35 a.m. Eastern Time, while most of humanity was asleep, a 14-ton piece of American rocket hardware slammed into the far side of the moon at over 5,000 miles per hour. No one on Earth saw it happen. No camera captured the flash. No alarm sounded. And yet, within hours, NASA scientists, amateur astronomers, and space agencies around the world were racing to answer a question that sounds almost too strange to be real. What exactly did we just do to the moon? This is not science fiction. This happened. And the story of how it happened, why it happened, and what it reveals about humanity's relationship with the last untouched wilderness in our solar system is stranger, more suspenseful, and more important than almost anyone realizes. Because this was not the first time a rocket has struck the moon by accident. And the last time it happened, the world got the story catastrophically wrong. To understand what NASA just confirmed, we have to go back. We have to go back to a rocket launch that no one thought twice about. We have to go back to a piece of space junk that spent 7 months quietly falling toward its own destruction. And we have to go back to the unsettling truth that humanity has been leaving pieces of itself scattered across the lunar surface for over half a century, mostly unnoticed, mostly unrecorded, and almost entirely unregulated. On January 15, 2025, a SpaceX Falcon 9 rocket lifted off the launch pad carrying 2 robotic explorers bound for the moon. One was Firefly, Aerospace's Blue Ghost 1, a lunar lander built to touch down softly on the volcanic plains of Mare Crisium as part of NASA's Commercial Lunar Payload Services program. The other was Resilience, a lander built by the Japanese company ASA, carrying the quiet hope of a nation determined to become the 4th country to land intact on the moon. Both spacecraft separated cleanly from the rocket's upper stage. Blue Ghost 1 would go on to make history, becoming one of the most successful commercial lunar landings ever attempted. Resilience would not be so fortunate, crashing into the lunar surface after a fatal miscalculation in its descent. But while the world's attention followed the landers, almost no one was watching what happened to the rocket that carried them there. The Falcon 9's upper stage, the very piece of hardware that had done its job perfectly and delivered to spacecraft toward the moon, was left behind, empty, unpowered, drifting. In most missions like this, engineers plan an escape trajectory, sending the spent stage safely past the moon and out into a harmless orbit around the sun. But this time, for reasons that remain only partially explained, that final maneuver never happened. According to NASA's own account, the rocket was never commanded to adjust its course to guarantee a miss. And so it kept falling. For 7 months, this massive piece of American engineering tumbled silently through the vacuum of space, caught in a slow gravitational dance between Earth and Moon, completely unguided, completely uncontrolled. It was, in every sense of the word, junk. But it was junk the size of a small building, weighing close to 10,000 pounds, moving at a velocity that would make Mach 10 look sluggish by comparison. It was a man named Bill Gray who first noticed. An amateur astronomer who runs a piece of software called Project Pluto, used by observers around the world to track near-Earth objects and space debris. Gray had done this before, using nothing but publicly available orbital data and old-fashioned mathematical persistence. He began plotting the rocket's trajectory months in advance. What he found was chilling in its certainty. This was not a near miss. This was not a close call. This was a collision course, and he could calculate almost exactly when and where it would happen. Astrophysicist Jonathan McDowell, a researcher at the Center for Astrophysics at Harvard and the Smithsonian, independently confirmed the numbers. The predictions converged. A used piece of SpaceX hardware, drifting for over half a year through the dark, was going to hit the moon on August 5, 2026, near a pair of craters called Einstein and Bell, on terrain bathed in lunar daylight but permanently hidden from any telescope on Earth. And here's where the story stops being simple. Because in March of 2022, almost exactly this same scenario played out. A mystery rocket, body-tracked for weeks by the very same Bill Gray, was calculated to strike the moon near a crater called Hertzsprung. And in the frenzy of media coverage that followed, headlines around the world declared with total confidence that the doomed rocket was a SpaceX Falcon 9 upper stage, left over from a 2015 mission that had launched NOAASDS COVR satellite toward deep space. The world believed it, Astronomers believed it. For weeks it was treated as established fact. Then everything changed. Gray issued a correction. Deeper analysis of the object's trajectory revealed that the object could not be the DSCOVR rocket stage after all. The orbital mechanics did not match. And so, the search for the true identity of the impactor began again, time turning toward an entirely different suspect, a Chinese Long March 3C rocket. The very booster that had launched China's Change 5 T1 lunar mission back in 2014, China's government pushed back immediately. A spokesperson for the Chinese Foreign Ministry stated publicly that the rocket stage in question had already burned up harmlessly in Earth's atmosphere years earlier, but American tracking data told a different story. The United States military confirmed that the Change 5 T1 rocket body had never re-entered Earth's atmosphere at all. It was still out there, drifting through interplanetary space, exactly where the trajectory calculations said it would be. On March 4, 2022, the mystery object slammed into the far side of the moon near Hertzsprung crater, precisely as predicted. But because the impact occurred on the side of the moon eternally turned away from Earth, no telescope, no satellite, and no human being witnessed the moment of collision. For nearly 3 months, the world had only a mathematical prediction and no visual proof. Then, in June of 2022, NASA's Lunar Reconnaissance Orbiter, spacecraft that has been silently circling the moon since 2009, captured something extraordinary. Comparing photographs of the lunar surface taken before and after the predicted impact date, scientists at NASA's Goddard Space Flight Center in Arizona State University found it, a fresh scar on the ancient lunar terrain, precisely where the mathematics said it should be. But what they found next made the story even stranger. It was not one crater. It was 2. Overlapping, nearly identical in size. An eastern crater, roughly 18 meters across, fused directly against a western crater, 16 meters across, forming a single, elongated double scar, unlike anything ever seen from a rocket body impact on the moon before. NASA's own lunar imaging team, led by principal investigator Mark Robinson, noted that this had never happened with any of the previous 47 known rocket body impacts on the lunar surface, including for abandoned stages from the Apollo program itself. Why would a single hollow, mostly empty rocket stage create 2 separate craters instead of 1? The leading explanation, confirmed years later through detailed research at the University of Arizona, was almost unsettling in its implications. A normal spent rocket stage carries most of its mass at one end, near the engines, while the rest of the structure is little more than an empty fuel tank. A single mass hitting the moon creates a single crater, but to craters means to masses. It means the Chinese rocket body that struck the moon in 2022 was not empty at all. It was carrying something else. An undisclosed secondary payload bolted to the booster, never announced, never explained, and never acknowledged by the Chinese space program to this day. Researchers who studied the object's light curve, the subtle flickering pattern of sunlight reflecting off its tumbling surface as it spun through space, compared it against thousands of computer-simulated debris objects to reconstruct its identity with near certainty. Their conclusion was clear. This was the Long March 3C rocket body from the Change 5 T1 mission, and it was carrying secret cargo to its own grave on the surface of the moon. So when SpaceX's own upper stage went hurtling toward the moon in August of 2026, the world watched with entirely different eyes. This time, there was no ambiguity about ownership. NASA and SpaceX openly acknowledged the object's identity in advance. This time, scientists were prepared. This time they intended to actually witness the impact as it happened, not stumble across evidence of it months later. NASA's Lunar Reconnaissance Orbiter was repositioned, timed to pass over the predicted impact zone roughly 7 days before the collision and 7 days after, hoping to capture direct before and after evidence just as it had with the mysterious Chinese debris 4 years earlier. Ground-based telescopes were mobilized. A decentralized global network of amateur astronomers prepared to point their instruments toward the lunar terminator, the delicate boundary between day and night on the moon's surface, hoping that if the impact plume caught the sunlight just right, it might create a faint, fleeting glow visible even from Earth. Scientists were candid about something remarkable. They did not know exactly what they would see. A research team from the University of Texas at Austin published a new paper on the Open Access Physics Archive. Arxiv just days before the impact, modeling the potential brightness of the debris cloud thrown up by the collision. Brent Gary, a project scientist for the Lunar Reconnaissance Orbiter mission at NASA's Goddard Space Flight Center, described the event as a rare opportunity to test their scientific predictions against real-world lunar physics, something that almost never happens on command. At the moment of impact, near the Einstein and Bell craters on the moon's far side, the spent Falcon 9 stage struck the surface, traveling at roughly 5,400 miles per hour, nearly 7 times the speed of sound. NASA estimated the resulting crater would stretch approximately 60 feet across and 12 feet deep, a permanent wound carved into terrain that has remained essentially unchanged for billions of years.
Oh.
And here is where the wonder of this story deepens into something almost philosophical. NASA scientists pointed out something that should stop anyone in their tracks. Impacts like this are not actually rare in a cosmic sense. Meteoroids carrying similar amounts of kinetic energy strike the moon naturally roughly every 6 days. The moon has no atmosphere to burn up incoming debris, no oceans to swallow the evidence, no wind or rain to erase the scars. Every collision, every scratch, every crater carved into its ancient face remains permanently written into the landscape. A silent historical record stretching back over 4 billion years. What makes this moment different is not the physics, it is the authorship. For the first time in a very long stretch of human history, we are not simply observers of what falls onto the moon, we are the ones dropping it there. And the scale of what we have already left behind is almost impossible to comprehend. Researchers tracking humanity's footprint on the lunar surface estimate that more than 200 tons of human-made material now rests on the moon, a graveyard of abandoned landers. Discarded rocket stages, crash probes, and scientific instruments accumulated across nearly 70 years of exploration. From the earliest Soviet impactors of the 1950s to the most advanced commercial landers of today, every mission that leaves Earth for the moon adds another artifact to this growing archive. And as private companies, national space agencies, and newly ambitious programs from India, Japan, and beyond race toward the lunar surface at a pace never before seen in human history, the question of what happens to the empty rockets, discarded stages, and abandoned hardware left behind becomes something no one can afford to keep ignoring. Because right now, there are no binding international rules governing space junk left on or near the moon. No treaty specifies how. Nations or private companies must dispose of a rocket stage once its job is done. No governing body tracks, catalogs, or coordinates the growing debris field drifting through the space between Earth and its only natural satellite. Each agency, each company, largely makes its own choices, quietly, with little public scrutiny, until an amateur astronomer with a laptop and a stubborn curiosity notices something falling where it should not be. There are signs that the culture is beginning to shift. More recent Chinese lunar missions have started directing their spent rocket stages into stable orbits around the sun rather than leaving them to drift toward eventual impact with Earth or the moon, a quiet but meaningful change in practice. SpaceX itself appears to be adapting its own procedures. At least one more recent Falcon 9 upper stage, launched in November of 2025 to carry NASA's ESCAPADE spacecraft toward Mars, was deliberately placed on a trajectory that will send it into permanent solar orbit, engineered specifically to avoid becoming the next piece of unplanned lunar wreckage. But that trick, engineers caution, only works for missions that are already headed toward the moon or beyond. The vast majority of spacecraft never travel far enough to make solar disposal a realistic option, which means the accumulation of debris around Earth and eventually on the moon itself is not a problem that is going away. It is a problem that is only beginning.
Oh.
Hold that thought and let it expand. Because the moon is no longer simply the next chapter of human curiosity. It is becoming a destination.
NASA's Artemis program is actively working to return American astronauts to the lunar surface, with the Artemis II crew having already completed a historic journey around the moon earlier this year,
Laying the groundwork for an
eventual crewed landing near the lunar South Pole. NASA has openly discussed long-term ambitions for a permanent human presence on the moon, a lunar base capable of supporting scientific research, resource extraction, and eventually a launching point for missions to Mars. Every rocket that will carry astronauts, habitats, rovers, and equipment to build that future will leave something behind. Every discarded stage, every jettisoned component, every piece of hardware too heavy or too impractical to bring home will join the growing catalog of human debris scattered across a world that took over 4 billion years to accumulate its current ancient face. And there is something profoundly strange about that. The moon has been struck by asteroids, comets, and meteoroids since the earliest days of the solar system, forming an unchanging record of natural cosmic violence, frozen in time under an airless sky. Now, within the span of a single human lifetime, it has also begun recording us. Our engineering, our ambition, our carelessness, our race toward the stars, one uncontrolled rocket stage at a time. The scientists studying the double crater near Hertzsprung, the strange twin scars left behind by China's secretive Long March booster, were not simply investigating a piece of space debris. They were reading a message written in impact craters. A message about hidden payloads, unclear intentions, and the quiet reality that not every nation racing toward the moon is telling the full story about what it is sending there. And the scientists studying the fresh crater near Einstein and Bell craters, formed by an openly identified American rocket, are documenting something equally important, a rare, transparent, scientifically valuable opportunity to understand exactly how these impacts behave, what kind of debris plume they create, and how future missions might use that knowledge to protect the historic and scientific sites already scattered across the lunar surface. Because make no mistake, the moon is not simply empty rock. It carries irreplaceable scientific value. The permanently shadowed craters near its poles may hold billions of years of frozen water ice, a resource future astronauts will depend on for drinking water, breathable oxygen, and rocket fuel. The undisturbed regolith across its surface preserves a record of solar wind particles and cosmic radiation stretching back further than almost anywhere else accessible to humanity. The historic landing sites of Apollo, Luna, and Change missions stand as untouched monuments to human achievement, vulnerable to disturbance from a nearby impact or in careless future landing. Every uncontrolled piece of debris we leave in space is a roll of the dice against all of it. So when NASA confirmed exactly what happened when the SpaceX rocket struck the moon on August 5, 2026, it was not simply closing the book on one falling piece of hardware. It was opening a far bigger and far more urgent conversation. A conversation about responsibility, about transparency, about what it means to be a species capable of reaching another world, and whether we are equally capable of treating that world with the care its ancient, silent history deserves. Because here is the truth that should stay with you long after this story ends. The moon does not forget. It has no wind to erase our mistakes, no rain to wash away our carelessness, no living ecosystem to slowly reclaim what we abandoned there. Whatever we leave behind on its surface will remain largely unchanged for longer than every human civilization that has ever existed. Longer than recorded history itself, silently outlasting every one of us. The rocket that struck the moon in August 2026 will still be there, scattered across the regolith near Einstein and Bell craters, when humanity's Artemis astronauts finally walk across the lunar South Pole. It will still be there when the first permanent lunar base opens its doors. It will still be there, quite possibly, when the first child born on the moon looks up into the black sky